Love, an insanely positive feeling of elation. Such a profound feeling, yet words fail us when it comes to describing being in love. All of us have experienced this euphoric feeling at some point of time in our lives. Haven't we all felt those butterflies in stomach, overwhelming joy in our hearts, and bliss in mind? As if we are high on something. The way we describe being in love sounds awfully similar to what drug users describe ecstasy high or marijuana high. What is love, and what really happens inside our brains when we fall in love? Hi, I'm Nanmure, and this is Neuroscience of Everything. In this Valentine's Day special episode, we explored the neuroscience of love. What is love? Well, depends on whom you ask. For centuries, talking about love was philosophers' domain. Many writers, philosophers, artists, and musicians have described indescribable love, but ended up making it even more enigmatic. In the East, religions have had a huge influence on the concept of love, at times blurring lines between romantic love and religious love. For instance, Rumi, a Sufi poet, proclaimed love for God is at its purest form. Some Hindu poets from 14th and 15th century describe their respective gods as their only and true lover, and vice versa. Nevertheless, love has always been described as noble, if not downright divine emotion. A mystic Indian poet, Kabir, describes the importance of love in his one of couplets. Pothi padi padi, jagmuwa pandit bhayanak hoy, ढाई आखर प्रेम का पढ़े सो पंडित होए, which roughly translates as entire world is engrossed in reading scriptures, but no one has become pandit, that is learned one, the one who understands 2.5 alphabet of love, prem in Hindi, attains the ultimate wisdom. As we move to the West, a Greek philosopher, Aristotle, pondered over the enigma of romantic love in very Aristotelian way. He proclaimed, love is composed of single soul inhabiting two bodies. Romantic love, despite its all divineness and nobility, was always associated with hurt, especially by poets. From Shakespeare's romantic tragedies to modern pop culture, all of them associates love with hurt. Hathaway's hit single from 90s, What is Love? Baby Don't Hurt Me, No More, summarizes it perfectly. Linguistic research suggests expression of love is a common thread across all the languages. Let it be Je t'aime in French, Ich liebe dich in German, Szeretlek in Hungarian, or Wo eine in Chinese. Love is a universal human emotion, observed across the centuries, countries, cultures, and races. This observation strengthens the notion that love is not only a universal human emotion, but must have common biological pathway. In recent times, it also became a theme of interest for scientists. Let us see what science says about love. In the beginning of 19th century, scientists began to investigate the complexity of love. Early scientific research about love was largely confined to the tenets of psychology, where psychologists studied the mind and behavior. Several theories were put forward. I'm including the link for psychology enthusiasts in the episode synopsis. But as a neuroscientist, I will be talking more about research clarifying brain mechanism of love. Neuroscientific research can broadly be divided into two parts: where and what in the brain. Part of the human brain involved and the neurochemicals involved in orchestrating the feeling of love. It sure does feel like we love someone with all of our heart and perhaps with all of our brains. But is there a part of the brain particularly affected by Cupid? Perhaps a love center? Or like a little love spot? If so, is it on the right side or on the left side of the brain? Thanks to recent advancement in brain imaging, especially fMRI, functional magnetic resonance imaging, one can take snapshot of the human brain without any scary surgeries. Scientists from Rutgers University, New Jersey, conducted a study where they showed a picture of the beloved person and another familiar face to the subjects. They found different areas of the brains were lit up when a picture of romantic partner was showed, compared to the picture of just an acquaintance. They found two distinct brain regions consistently lighting up in all 17 study participants: the right ventral tegmental area and right caudate nucleus. These areas are dopamine-rich and associated with reward and motivation. What does it mean? For the uninitiated, dopamine is a neurochemical which governs our motivation. For example, something as mundane as eating chocolate chip brownies is a rewarding experience. In terms of romantic love, the dopamine reward system orchestrates the general arousal, which also includes sexual attraction. The way one feels joyful about eating that brownie, something similar might be at play when you see, hug, or spend time with your lover. Romantic love has many correlates, which also include sexual attraction and arousal, which is Mother Nature's way to ensure we keep propagating our species. Indeed, ideally love and sex complement one another. Maybe that's why people refer to sex as making love. However, our romanticized ideas of selfless, noble, and passionate love begs a question. Can our brains differentiate between sexual attraction and love? Is there a distinction for the brain between love and lust? In addition to the reward areas, a study by Aron and colleagues found involvement of the limbic system, a system which is known to be involved in emotional processing in brain. The convincing evidence for passionate love has different neural correlates than lust came from a series of studies by Cassiopo and colleagues from the University of Chicago. An interesting set of studies found two different regions of the brain associated with love and lust: the anterior insula for love and a posterior insula for lust. Of course, it is just a correlation, and there might be more to love and lust after all. But interestingly enough, people with impairment in this love region were unable to make decisions about love. So no love for these patients, too bad. On a lighter note, poets and philosophers among audience can take a sigh of relief now that neuroscience also suggests that passionate love is a special emotion and not simply lust. In this part, we talk about neurochemicals and love. When we see on-screen couple or even real-life couple that make up for couple goals, how we describe them? Amongst other things, we naively say that they have great chemistry. Does chemistry have to do anything with the biology of love? Maybe more than you think it definitely has. Speaking outwardly, we human, like many animals, are sensitive to love pheromones. A simple experiment carried out at University of British Columbia in 2020 showed that smelling your lover's shirt improves the quality of sleep in study participants. The improvement in sleep quality was small but significant. Now, let us take a deep dive into the neurochemistry of people's brain who are in love. 3 neurochemicals keep showing up in many studies exploring the mechanism of love: dopamine, serotonin, and oxytocin. Dopamine, which we spoke earlier about, is also associated with addictive behaviors. In many ways, love can feel like an addiction, and it is no surprise that dopamine pathways are involved in certain aspects of love, particularly compulsive behaviors. However, more research needs to be carried out in this area. Serotonin. Serotonin is a neurochemical involved in maintenance of mood and is also dubbed as happy hormone. The imbalance of serotonin is linked to several psychiatric disorders, such as depression, anxiety, and OCD. But in the context of love, serotonin seems to play a supporting role to exhibit the happiness component of love. Oxytocin, last but not the least by any counts, is a neurochemical best known for its ability to induce labor at baby birth. Oxytocin earns its moniker of trust hormone or love hormone from a very famous Nature paper from 2005. The paper was published by Markus Heinrichs from the Department of Clinical Psychology and Psychotherapy, University of Zurich. In this paper, authors showed that oxytocin improved trusting and emotional bonding behavior in humans. Further studies kept confirming this effect and adding more to it, such as fidelity in relationships, monogamy, trust, and empathy to the gamut of oxytocin and love. In no time, oxytocin went from pain in the tummy molecule to love in the heart molecule. Paul Zak, one of the authors of original Nature paper, made a public case for oxytocin in his 2011 TED Talk. He brandished a syringe filled with oxytocin, dubbing it the moral molecule. He told the audience, "It is so easy to cause people's brain to release oxytocin." His favorite method? Hugging. In fact, he recommended 8 hugs per day. To introvert and germophobes' nightmare, some people took it pretty darn seriously. However, later studies could not confirm all the effects of oxytocin. Scientists sort of fell out of love with so-called love hormone. Well, that did not stop opportunistic entrepreneurs from making oxytocin nasal spray. Can we make a stranger love and trust you with a whip of oxytocin? The answer is very likely no. Needless to say, oxytocin nasal sprays don't work. Besides, your potential partner might find getting sprayed right in the nose on first date pretty annoying, so I wouldn't recommend it. In conclusion, to put it very unromantically and to the dismay of poets and romantics out there, love could be just a fleeting high, fueled by brain chemicals in certain brain regions. We know these neurochemicals are a partner in crime of love and are present at crime scene, but it is not necessarily a sufficient condition to explain love in its entirety. It will be lovely to see more efforts invested in this research, and one day, we might know what is love, for sure. We are almost towards the end of this episode. We began with the question, what is love, and what happens in our brains when we fall in love? We took a short journey from philosophy to modern neuroscience. Since the dawn of civilization, mysterious things were often explained by philosophers. Well, until scientists could do it in entirety. Maybe same is true for love. Well, let's admit we do not understand everything, and like everything else in life, neuroscience behind love is more complex than we could ever imagine. But hey, I hope all of us have learned something today. In the end, I would like to invoke Sufi philosopher Rumi and leave you hopeful thought. What you seek is seeking you. Maybe even the love of your life. Happy Valentine's Day. I would like to thank Dr. Ruhi Deshmukh, a very accomplished scientist, for being the inspiration for this episode. Miss Yvette Joshi, a very talented pianist, for her original piano tracks recorded for this episode, and Mr. Tiago Ribeiro for help with the audio setup. Thank you very much for listening. If you like this episode, do not forget to share and subscribe on iTunes, Apple Podcast, Spotify, or wherever you get your podcast from. In the next episode, we talk about neuroscience of meditation, a pertinent topic in the socially isolated and stressful COVID times. Until then, take care, stay safe. This is Nand Mule, and you are listening to Neuroscience of Everything.